thanks for coming. And yeah, well, I'm going to be talking about some serious IoT wars. And well, you can already see from the title and from the title of the whole talk, I grew up with Luke Skywalker and his friends, so please be prepared for some Star Wars references in this. First of all, who am I? Well, my name is Christofer Dutz. I'm a senior IT consultant for a company Codecentric, and I'm a total open source enthusiast. So all of my free time goes into several open source projects. I think I lost count in how many projects I sort of contributed to. I think it was sort of 30, 40-ish thing. Usually I'm sort of a drive-by committer, sort of using things, didn't work, submit a patch. But with Apache, I sort of stuck. I've sort of started with Apache Flex, but well, it has grown to sort of, I'm currently sort of committer of 10 projects. I think PMC of 5 or 6. Was invited to become a member of the foundation, and well, now I've got another one of these really super important titles I got to add. I have the honor of being the VP of Apache PLC4X. But to sort of build the bridge to why is an IT guy doing this hardware stuff? Well, I'm also son of an electro engineer, so I remember my father brought back this Commodore C64 when it was presented at the Hannover Messe. Yeah, well, the computer that I was playing with after that was a Siemens S5. So, well, he brought that back from home, and I found it interesting, and I always liked things, real things, not virtual things in somebody else's computer. So that's why I sort of had this thing with IoT. At Codecentric, usually we have one day where we can work on open source. Well, for the past 2 years, I had the pleasure of sort of being able to work on this 100% of my time. So why was I able to be doing this? So, well, let's say Industry 4.0 is everywhere. It's sort of like the buzzword everybody uses right now, and, well, most people don't really have a really clear impression what it actually means. Sort of like the cloud 10 years ago. Everybody wanted the cloud, but didn't really know what to do with it. But if you sort of dig a little deeper, what it comes down, it's sort of IoT technology, it's sort of cloud technology, it's big data, and machine learning, and, well, they like to call it artificial intelligence. I tend to sort of, well, call it sort of like smart algorithms on big data. So this is totally a thing. So I haven't been at a single company in the past 2 years where they didn't sort of have any sort of chief of Industry 4.0 or chief digitization officer, but usually they didn't quite even know what they were working on. But everybody's sure the trend is going to be sort of going up. So I intentionally didn't sort of put any source underneath because I had multiple sources. I wanted to overlay them. But everybody had different measures, different bases on which these numbers were calculated, so it was hard to sort of put them over each other. But if you sort of just type, I think that was just sort of IoT growth chart in Google, well, that's sort of what you get. And it doesn't really matter what scale you put it on, it's sort of always sort of an exponential growth chart. But, well, even if they all want it, it's still completely new to them. Usually there was a sort of what we do IT in the industry, they usually call it OT, sort of operational technology. It's sort of they do the wiring for the production plants. They do take care of the Windows servers or the Windows PCs running all the stuff. It's mainly Windows based, and they have absolutely no know-how about all of these IoT, cloud, big data tools. So what they do is what they always did. So whenever they had sort of, well, let's say they have one of these PLCs. That's an S7 1200, sort of the entry model. And, well, let's say they had a lot of these, and they were too slow. So they went to their vendor and said, well, they're too slow. We need a faster one. So they provided a faster one. So it was always the case that, well, the customers needed something, the supplier shipped it. And that's what they tried here too. But these topics are also completely new to the vendors. I think most of the big PLC companies, they have absolutely no footprint in sort of big data, machine learning, cloud technology. They were sort of, the software part is pretty new to them. But they don't want to sort of admit that, so what do? Well, they start buying up all these companies. So that was what was tweeted for the last 2 years or so, all this, well, company X is buying a startup Y for an insane amount of millions of dollars, just to sort of buy in all this stuff they were missing. Also, they're quite sort of very actively trying to acquire new skilled people without buying their companies. But, well, right now I have to admit, to me it sort of looks like they're sort of delivering, but they're not delivering very well. So they're sort of currently working hard on destroying their reputation. And the other thing is, well, they are now sort of, they bought all this cool IT tech stuff, but the way they're sort of bringing it to market is still the same way they've been doing it for 20 years. It's always closed source, even if it might be built up out of 95% open source. They have very restrictive licenses. Sometimes they have clouds where you have to sign that all the data you send into the cloud becomes the property of the cloud vendor. I mean, come on, if you're sort of Coca-Cola and you're submitting your Coca-Cola formula into the cloud, well, I wouldn't trust them just selling that to Pepsi. They're insanely expensive. So I remember in the 90s when I first heard how much a license for an Oracle instance was, I thought, who on earth would be willing to pay that? But it turns out, if you go to the industry, license costs are just out of this world. Sort of like bridges to get data out of a network. Well, you're easily paying 800,000 euros in license costs a year for one machine. And that's sort of just, that's just totally wrong. And last not least, well, usually if you've got the software from vendor A, well, it will not talk to the devices of vendor B. So if you decided to go one road, you're sort of either not able to talk to everything, or you're just sort of locked into that road and just can't switch. So for me, sort of industry software sort of comes down to this. It's sort of the Death Star. It's insanely expensive. I think the US guys here, you had this really cool petition where people demanded that Congress sort of discusses building a Death Star. And I think the numbers they put in there, they were really, really great. Well, I think we all agree a Death Star is highly proprietary. Well, you can't do very much with it except blowing up planets. It is pretty inflexible. You know how long it takes to get around a moon. And yeah, well, in the end, it's also very insecure because, well, come on, we all know a one-man spacecraft just blew it up in no time. But, well, these topics are sort of all we've been doing for almost a decade. Modern IT, Apache has sort of all the software we need to build great industrial software, the solutions. We've got plenty of skilled people because, hey, come on, we built this stuff. We know how to use it. And all the industry needs to do is sort of just ask us. So sort of between Christmas and New Year's Eve, there was this one tweet, and I found it really, really interesting. And it was by a company called Bain. I have to admit, living in Germany, I haven't heard of them, but I think in the US they're sort of a big deal. And they seem to have a lot of customers, and so they asked customers sort of in the production industry about what they think are the most significant barriers in adopting sort of these Industry 4.0 solutions. And we just look over here. I think this might be a bit laggy with this. Yeah, I'll just not do it. At the topmost, you can see security. Well, that's what they're feared about most. Well, I agree. IT-OT integration. So they have these IT systems. Let's say Linux, cloud systems, AWS, but Their OT systems are usually just plain old Windows systems. So how do you integrate those systems? Sometimes unclear return on invest. Well, the first year, I was traveling around. Everybody was wanting to do Industry 4.0, and when I asked them, what do you want to do? Well, they said, yeah, well, at first we're going to start collecting all the data. And we'll just pray that next year we'll have an idea what to do with it. So it's sort of difficult to get funding for activities like that if you don't really know what you want to do. Then they have the problem of technical expertise. Well, they would like to do cloud stuff, but they don't have anyone who knows how to do it. Interoperability. I said they have very proprietary systems. They're just not made for talking to each other. Data portability. There's a huge amount of different ways of expressing data. Sort of, is this, which bit representation is this integer value or this floating point? So it's sometimes not that easy to sort of just get data from one system into the other. Vendor risk. Yeah, if you decide to go down a vendor lock-in road, what happens if that vendor sort of just dies? Well, guess if you go with Siemens, the chance of them just stopping to disappear is probably going to be pretty slim. But if you decide to go with a smaller vendor, what happens then? Transition risk. Well, if the worst case happens above, well, how do you get your stuff over? Legal issues. Well, that's a huge thing, because if you start reading these license agreements of the industrial stuff, it's really, really difficult because they write all sorts of stuff in there. Some of that is sort of legally binding everywhere. Some of that is legally binding only, well, let's say in the US. Some of that isn't legally binding at all. So you always have to have some sort of lawyer just look on this and find out which of the rules apply and what do they mean for you. For example, one thing I really, really like is whenever I start implementing a new protocol, I usually contact the vendor. And, well, sometimes they send me hardware for free and documentation, and sometimes they threaten me to sue me to hell. Usually they say, yeah, but everybody signed that you are not allowed to reverse engineer these protocols. Well, living in Europe, being bound by European law, well, they can write everything they want into in their license agreement. I usually tell them they should just cut that, print pictures of cute kittens, because it would sort of legally have the same impact, but it would sort of look nicer. So you really have to know your legal basis there. Network constraints, yeah, also a fun thing. Everybody just wants to collect all the data and pump it into the cloud. But if you start doing the math a little while ago, we sort of had a proof of concept for a car manufacturer, and they wanted to sort of collect a certain amount of data in a certain interval, and we did a little bit of math. So, yeah, well, we need to pump 15 gigabytes of data per minute. Does your internet connection support that? So, ooh, well. And last not least, vendor lock-in. So let me just concentrate on the barrier connectivity, because that's what PLC4X is about. Sort of sums up to those 3 bars. Most major vendors of industrial hardware they define their own proprietary protocols. And this was sort of a result of these things sort of being built as standalone machines. Nobody thought of connecting them. And they were doing their jobs really nicely, until people started asking, yeah, I want to integrate that into my control. I want to build a control system. I want to talk to these devices. So the vendor sort of invented a protocol to do that. And now, well, now we're sort of at a situation where we want to connect all the things together, and now everybody's just talking a different language. They're usually completely incompatible with each other. There are some standards. For example, this device can speak S7, Profinet, and Modbus. And let's say Modbus is sort of a standard, sort of every PLC can talk, but you can do very limited things with it. And if you really want the good performance, you have to speak S7 with it. There are some standards, but if you use them, well, you don't get very far. There's no universal way to communicate from the software side. So there are some available drivers out there, but they're usually GPL licensed. And they were usually written in the end of the 90s by people learning Java by just porting C++ code, making it sort of compilable in Java. So that a lot of these drivers have sort of this, like in C you had with underscore separated method names starting with big letters, and sort of, yeah, it's not fun looking into those. There's a new protocol called OPC UA. Well, they started planning that 10 years ago, and let's say a sort of usable version has come out last year. So summing it up, this is the problem. Everybody knows Star Wars. R2-D2 usually just beeps and blinks, and Luke, well, doesn't really understand him. So that's the situation we currently have. I mentioned OPC UA. I'm explicitly talking about this because it is currently being sold as sort of being the silver bullet to solve all these problems. But so it's a standard for inter-machine communication. It's sort of defined by a huge amount. I think every company sort of building PLCs is sort of involved in this. So it is, if you go to their website, it's sort of the full screen, just sort of like the Apache. If you print all the Apache logos, well, double that, and sort of that's the amount of companies involved there. And you can imagine if you put 400 companies together to discuss something, they will probably take a while to release something. They've been working on it for about 10 years. It sort of defines how data is transported from A to B, but goes a little bit beyond that. It also defines the semantics. So you're not just pushing an analog value as an integer over the wire. You're also saying, well, this is an integer value in this encoding, and it has a min and max, and it sort of is going to represent a pressure value. So you get a little more context. But currently, it's absolutely not a solution for me. Let's say I said the standard was released in a really usable form sort of autumn last year. And I think the numbers I recently saw was that every fourth PLC being sold supports OPC UA. You can imagine one of these machines sort of usually lives for 15 to 25 years. And we now have sort of a year where 1/4 of the sold PLCs support OPC UA. I think you can do the math. You won't probably have anything sort of like 80%, so I think we'll be talking 2 or 3% being able to talk that. I think the protocol being able to do a lot is sort of pretty over-engineered for most use cases. There are some use cases where it makes sense, but I'd say for most use cases it is over-engineered. And sort of, yeah, this makes it sort of the performance being, well, let's call it less than ideal. I'd rather say it's sort of catastrophic. For me, currently, it's sort of like trying to fly the Millennium Falcon while there's sort of a Star Destroyer attached to it. I bet you know it's sort of, that's how a PLC feels if you turn on the OPC UA server. It's just sort of becomes sluggish. Sometimes it just stops working because it's so overloaded. So, for example, in a field test, those were tests done by Siemens. So it wasn't sort of usually the good thing if you sort of benchmark something, you get to set the field. So you can sort of show off your numbers a little. But that was what Siemens tried to do in that one case. And they were able to sort of get 200 data points every 2 seconds out of a PLC. And those weren't the little ones here for $150. We're talking about the 30,000 big S7 devices. And if they went a little bit above the 200 data points every 2 seconds, the PLC was overloaded and shut down. You can imagine if you've got a production line with, I think in that case it was 1,200 PLCs sort of working together. If one shuts down, that's not good. And well, if you're talking about machine learning, well, sort of, 200 data points every 2 seconds, that's sort of, yeah. The other thing was the protocol, I said, it's pretty heavy. The test server, so they had sort of like, you just requested virtual machines, yeah? It was sort of booleans, but also a lot of short values, sort of real numbers and stuff like that. So they had 2,600 data points defined, and the cool thing is, being such a big manufacturer, they sort of had every, or a customer, they had all the manufacturers sort of, they said, you have to provide your PLC programmed in a way that I can read this. And it was sort of the same data structure on all of these PLCs. It was sort of a wild mixture of Boolean values and sort of floating point numbers and integer values. Yeah, so the thing was, there you could sort of request in their data center small, medium, and large virtual machines. So what they did, they sort of requested a medium one and wanted to collect data on them. And one of these virtual machines was just overloaded when processing more than 20 PLCs. The thing is, they wanted to collect on 26,000 PLCs. So you can imagine the number of servers you need to do that. And it was expensive because even if they just sort of had to sort of like just rebuild all of their factories, so they all had really brand new PLCs, they would have to pay 800 euros per PLC to turn on the OPC UA support. So what we need is we need a C3PO, because that was always the guy sort of translating what R2 said. And well, let's say PLC4X is exactly that. PLC, that's sort of our mission statement. Sort of PLC4X is a set of libraries for communicating with industrial programmable logic controllers using a variety of protocols, but with a shared API. And the shared API part is where it sort of differentiates itself from the rest. So please pay attention to my maximum Photoshop abilities here. Yeah. So what is Apache PLC4X? Well, mainly it's sort of built all around this one module called the API. So it's just one dependency you need to add to your project. But it's also sort of has a big set of integration modules. So you don't have to use the API directly. You can sort of use an integration module and just use it in Camel, in NiFi. We've got for Apache Kafka, we've got direct integrations for Logstash, for all sorts of software. And I think I'm going to have a slide with all the ones I have a few slides later. Currently, it's called PLC4X, and most of the stuff we're currently doing is sort of in Java, but we're working hard on porting all of this to C++, to C#, to Python. We already have the constructs, the builds work. We just need the manpower to sort of implement the APIs, because we didn't want to do what is sort of quite usual quite now. Sort of somebody writes something in Java, and if you want to have a C++, you just sort of cross-compile it, and then you have this sort of all the Java concepts in C, which is sort of not that nice. So what we wanted to do is sort of, we wanted the API module to be implemented by people native to the language. That sort of gives the look and feel of being a real C++ or C library. But we'll be doing all the heavy lifting of the encoding, decoding, protocol stuff. That's all going to be generated. The generator is already done and it's working nicely. But we're still working on the sort of the heavy lifting for implementing the API part. We're also going to support Scala, C, JavaScript, and stuff like that. But I think this mainly depends on who sort of joins our team, because you don't want to have me implement something in C or JavaScript. That would sort of not work that well. And so the final goal is sort of to be able to write software that runs almost independent of which PLC you're using. The things you can do with PLC4X is quite limited. So all you can do is sort of read data. You can write data. You can subscribe for if the PLC supports sort of value changes, events, and stuff like that. We're going to support calling functions. So sometimes you can call a function in one of these, sort of like please go into the cleaning mode, and then it sort of positions stuff differently. As we're implementing more and more protocols that allow this, to also browse resources. So I can connect to a PLC and ask it, what do you have to offer? The protocols we currently support is sort of Siemens S7, that was sort of the first we implemented. Beckhoff ADS, Modbus, both TCP and via serial port. Ethernet IP, OPC UA. We just started working. I think I just stated a release where we have the Alan Bradley AB ETH as a sort of released driver. Alan Bradley DF1, that's a serial protocol. I'm currently working hard on BuckNet. Amazon Delta V, we were the first people to be able to talk with Delta V systems. Privately, I'm sort of working on KNX-Net IP because I want to talk to my house. In the near future, we'll probably be tackling the newer Siemens protocols and especially stuff like Profinet. So with Profinet, we'll be sort of going down one level more because with Profinet, we'll be able to sort of talk directly to the sensors or listen to them. So we've got connectivity covered with PLC4X, and well, we've got the legal stuff covered by being at Apache, because we have the license that is sort of everybody sort of likes, and we made sure that everything we do in PLC4X is absolutely 100% safe to use. So we weren't doing anything that is sort of bad. So we're absolutely safe on this side, and by this, our customers are safe. As I mentioned, we have integrations to other projects, namely Calcite, Camel, Apache Agent, Apache Kafka Connect. That will sort of, I think in the next month or so, Confluent will also probably have this certified, and it will be available in their sort of, I think they have this web store where you can just click it and it runs. In Vegas, we finished the Apache NiFi integration, and 2 or 3 weeks ago, we had a Logstash integration. We also found a nice project in Vegas called Streampipes. That's probably going to be called Apache Streampipes pretty soon. And as soon as we get the first seed-type drivers, I'm definitely going to put all my effort into getting it working Apache Minute, because I think we can do a lot of really great stuff there. Eclipse Cura, EdgeX Foundry, those are sort of bridging over to the other foundations. Yeah, well, and the Open Hub guys, they would definitely like to have some not GPL stuff. Yeah, so as I said, working on the seed-type stuff. And here a little architecture picture. I sort of stopped adding all the drivers and all the integration modules because otherwise you couldn't read anything, but I guess you get the point. If you're writing an application, well, you can just use the PLC4X API directly, or you just use one of the integration modules that sort of uses that. But you don't have access to the actual driver. So what happens here is sort of you just ask the API, give me a connection to an S7 device, and that sort of looks through the class path and looks if there is a driver available for servicing that. So, and this makes it really easy to sort of add own drivers. So the API for providing drivers is very easy. So if you, for example, have sort of 50% Siemens devices, sort of 45% Alan Bradley devices, and then you've got some handmade ones, sort of like the apprentice sort of built them and you would now want to integrate them. Well, you just have to write a little PLC4X driver for that protocol, and you get all the integration into the other stuff for free. So, this being a tech conference, here's a little example of the native API, and I hope I can find my mouse. That was not my mouse. Ah, there it is. Okay, it's a little laggy. So what happens here is, so at the top, you ask the driver manager to get a connection. So it's pretty similar to JDBC. So the important part is here, the first part of the string, sort of S7. By this I say, please driver manager, I want a connection to something using the S7 protocol. And if it finds it, it sort of passes it along to the driver. and that is able to parse the rest of the URL. So in this case, it's sort of a typical IP address, and at the end, you have to specify so-called rack and slot. That's sort of usually always 1/1, but it can differ. So this is all you need to establish a connection to that device. So you now got a connection, and now you want to send a request. We do that by using these builders, and we're also sort of preparing on shipping multiple versions of drivers. So a lot of people are very, very sort of afraid that software could manipulate these devices. So they are really wanting a sort of a read-only driver. So what we did, we wrapped everything with these optionals. So if you're sort of using a read-only driver and you want to create a write request, this optional will probably return false. So I can't use it here. Here you can see. So well, I guess every driver will have a reader, but we didn't want to sort of do it any differently for reading. So you just ask it if it is present. Well, if not, well, this connection doesn't support it. So if it did, I get the builder, and then I start adding items. And what we did here is, this is where we sort of bridge the gap between software developers and the ones building PLC programs. Because this is something we can work with. This is something, does anybody of you know what this is? What does this mean? Yeah, well, it means I want to read the value of the first digital output pin of my PLC. But the thing is, the guy developing the PLC program, well, he wouldn't know what we mean with that. So this is what he understands. That's what he has in his IDE when he develops the program. So the idea is sort of, we want a pressure value, or we want to, is this switch turned on or off? And we label it, switch A, turned on. And then we ask the guy and say, what's the address for this? And he can just respond with that. So this is where we sort of bridge the gap between the IT and the OT. So now we built this, hope scrolling works, okay. So what we do now is sort of, we asynchronously sort of send this request. And in this block down here, we sort of just define what happens if we get a response, well, or if something went wrong. I'm just sort of skipping the theoretical possibility of the thing failing, just for simplicity of code. And what we do now is sort of, if we get a response, we can iterate over all the names or the aliases that were returned. When doing a normal read request, this will probably always be all of them. But assuming you subscribe for changes, so if you want a value, if it changed, then you really have to know which of these values is this. And this is why sort of, and it will probably not always have all the values, just the ones that changed. So this way we can sort of iterate over all the returned fields and especially check if everything was okay. Yeah, because imagine sort of asking for 100 addresses and 2 or 3 of them, well, didn't exist or something was wrong. It's sort of stupid to have everything fail. So we can check per field what happened. Yeah, and well, if everything was okay, you can see over there, well, we'll just get the object and print it out. Any questions? I guess most of you wouldn't be using the native API anyway, but it's sort of, I think it might help to sort of get the idea. And the good thing is, this just sounds pretty straightforward, but when talking to a PLC, it is actually not quite that simple. For example, if I want to connect to this device, I have to log in into the protocol goes over 3 layers on top of TCP, and I have to log in and negotiate different parameters on each of these levels. And this is just something I, as a developer, don't want to deal with. And PLC4X wraps all of this complexity. If I want to talk to a Beckhoff ADS, I can't just send a read message and get it back. I have to subscribe for the read. I have to execute the read, and in the end, sort of release the subscription again. But as I said, I don't want to deal with this. That's why the drivers take care of this. But the good thing is, with all of this, sort of, we've got almost all the bars covered. Stupidly, the first bar is the one causing the most problems when I was talking to them, because whenever I came there, it was usually always sort of the killer question: are your drivers certified? And I would say, yeah. Well, that's when I usually said, no, they are not certified, and they will never ever be certified, because that would mean not only certifying our code, but also all dependencies we've been using. And that would just never happen. The industry is able to do that because, I said, one of these systems costs 800,000 euros. Well, you can do a lot of stupid stuff with 800,000 euros. They're totally paranoid about sort of industrial espionage, compliance rules. So if I'm sort of having a company in Germany and I produce some drink and I want to sell that in the US, well, I have to apply to the FDA rules. And they are very, very strict when it comes to sort of separating networks that you can't interfere with them. This makes it very, very difficult to any sort of data science approach, because the stupid thing with data scientists is they usually work best if you give them data. And usually they don't work in the sealed environments. They have their hip lofts where they sort of do all of their creative data stuff. They don't perform well in sort of wearing helmets and special clothes in some closed environments. Yeah, as I said, usually they come up with validated software. And as I mentioned also, reading data has an impact on a device. So if I ask that thing too many questions, it will just shut down. So this is how it currently looks. Well, this is sort of a simplification. Usually you have some PLCs, and you have some control systems, usually set up redundant. And then it sort of, data goes into this thing called a historian. And that is sort of, I've never seen a computer like that. It sort of looks like a big desktop, but it is sort of, it's a little bit bigger. But when I tried moving one of them, it was so heavy, we had to take 3 people to move it. It's sort of, I was told sort of the hardware costs are a 6-digit number. And all it does is sort of like, it's a really stupid relational database in which you just dump data. And you can't do things like, give me this and that value between time A and B. No, you have to sort of go through all of it and filter out of the stream what you want to have. Usually you don't connect them directly, because in all use cases I've ever seen, there was usually 1 or 2 systems in between the control system and the historian. So the thing is, if a data scientist wants a new value outside, they had to adjust about 5 systems, which is sort of the cost of the process of extending it was insane, and the license cost of every device in between was insane. So what did we do? Well, we just thought, well, why do we have to do it that way? And we came up with something we called the passive mode drivers. Well, initially we called them promiscuous mode drivers, but only people knowing the promiscuous mode on network interfaces knew that, and everybody else thought, oh, this is something I don't want to work with. So passive mode drivers works better. And they only passively monitor what's going on in the network. They capture a request and a response, and from that they can extract at time X value Y has value Z on device. Damn, what's after Z? The cool thing is, as we're not adding any extra load, we have absolutely 0 impact on the hardware. We have 0 impact on the network, and not having to sort of validate the software. Well, we can make it really cheap, sort of like €0. Still, there was sort of, they were hesitant because, well, if you just promise them to not send a byte, well, they don't really trust you because you're not validated. So what we needed was something we always had in our chart, sort of like, yeah, and then comes the data diode. It's sort of a network device that lets data only pass in one direction. Not like a firewall that sort of lets you establish a connection, which can be bidirectional. It should really be sort of a thing that bytes can only pass in one direction. And unfortunately, there existed a few models of these things, but usually I think the cheapest one I found was 50,000 euros. It was sort of military grade stuff. I thought, can't be. How can something be that expensive that does something so simple? And I happened to have the opportunity to sort of meet somebody from a company building some network stuff, and I talked to him about this idea. And, well, 5 weeks after that little chat, we had this. This is sort of the first hardware produced to support passive mode drivers, and it's got a price tag, I think, of $500 at the moment, but I guess if sales should go up, I guess they will be able to sort of lower that price even more. But I mean, we're competing with 800,000 euros of license costs, so I guess $500 for a data diode is a no-brainer. So how does our system look like? Well, we have this network switch, and we configured sort of the one port as an uplink port, attached the network diode to it, and on the end, we had a Raspberry Pi when we did the demo. And that just intercepted the whole network and sort of made all the data available in almost real time. And the cool thing was our little Grafana dashboard we had stored stuff in Influx, had sort of a Grafana dashboard. And the cool thing was our charts and our gouges, they were moving faster than the ones on the screens of the control system. That was awesome. Yeah, so in the end, it looks like we managed to get sort of all of this covered, except the unclear return on invest and the technical expertise. But that's why we're here. That's what we do. We can help the industry just color these last bars by sort of bringing open source and our expertise into the industry. So, what's new about the project? Well, we graduated on 23rd of April, and well, we just noticed that we did one thing really bad, because I think in the Podling Shark Tank, I think the measure of being a real Podling by having a -1 vote by Justin, we found out that we actually sort of passed through the entire incubator without getting a single -1 vote by him. I hope they won't downgrade us again. What I've been working for the last half year, so if you sort of look at the releases, speed has sort of slowed down a little, but it was because we were working in the background. So for about 3/4 of a year now, I've been working on a way to specify a driver protocol in a machine-readable way and generate all of this code by a Maven plugin. And that's working really nicely. We finished the templates for Java, and currently we'll be starting porting that to other programming languages. But the great thing is, it's sort of our idea that you have a protocol module that has the specification in it. You have a template module for every language you want. And then you can sort of just start shipping protocols by adding a new protocol module and just using the Java language template and the new protocol module and just have a sort of 95% of the code just generated. And that makes it possible to sort of keep all of these in sync, because it would have been a total nightmare to sort of maintain this N cross M matrix of implementations. Somebody finds a bug in the Java S7 driver. Now you have to sort of port that to Python and C and C++. It would have been a nightmare to keep that in sync. I'm currently working on actually implementing a PLC mock, because a lot of people were sort of asking, yeah, I really want to try out your project, But you need hardware for that. Well, it's sort of the point of PLC4X to allow you to talk to hardware, but it also sort of makes you sort of have to have hardware. But what we're doing right now is we're using the generated drivers to also implement the other side. So we're sort of building up some, I'm building up some system with which we can sort of have some sort of predefined scenarios where we can write tutorials where people can try out things without actually having hardware. So what's next? Well, as I mentioned, we want to use the generated drivers to port this to all the other languages. We wanted to start with these restricted versions. So I mentioned read-only drivers, but also passive mode drivers that don't have any code for sending out data. My topmost priority is definitely supporting Minute, but also supporting EdgeX Foundry. And we also wanted to start working on query optimizers. So if you sort of read very bits in close proximity, it's sometimes easier to just read a byte than 3 bits. And, well, a lot of testing. And the cool thing is I mentioned that chart going up. Those were the download statistics of PLC4X. So I see quite a correlation. Have to admit, if I would have done this chart today, there would have been this bump because we just didn't release for sort of 4 months or so. But in general, the direction is very, very obvious. So the rebellion needs you. So do you know C++, Python, or whatever? If you're good in brainfuck, we don't care. We will provide drivers if you help us write the code. Also, we need people to just try it out. Give us feedback. Test it on some real devices because, well, we have quite a lot of devices, but, well, quite a lot. I think we have 5 or 6 different PLCs, but there's a huge zoo of different PLCs out there. So we need a lot of testing, feedback. If you like writing documentation, if you're good at web design, our website definitely needs some love. So if you want to help, please sign up to our mailing list, dev@plc4x.apache.org, or follow Toddy at Twitter. He usually tweets quite a lot of the cool things we're doing. If you want to also get the fun pictures, well, sign up for Christofer Dutz. Yeah, start using it, file bugs, submit pull requests. I always like people submitting pull requests. And just join in the discussion. Or, well, even if you're just talking to some friend who's sort of talking about his pain with digitization in the industry, just spread the word and help us color the last 2 bars. Thanks for listening. Hope I was on time. So, are there any questions? Come on, don't be shy.
So could you talk a bit about your relation or your employer, Concentric, sponsoring the development? What does he offer?
Yeah, okay. So the question, yeah, well, you got the question. So the reason Concentric is sort of paying me for 2 years to sort of work on this is generally that sort of we have a lot of awesome people able to sort of do all of this big data, cloud, machine learning stuff, but sort of currently, we're sort of mainly working sort of insurance companies, banks, and sort of the percentage of the industrial contracts was sort of lower than we expected. And the reason for that was sort of that, first of all, our tools couldn't talk to theirs. I think the usual approach would have been to have another one of these sort of gray boxes, but with less LEDs that sort of just collect data and store that in some CSV file that you could mount in a Windows share and parse. So that was sort of state of the art. So with our involvement in this project, we sort of opened this whole market for our services. We know it also opens it for all the others, but, well, we don't really care because it is such a huge market that I think we can all do really good stuff there for the next 10 to 20 years. Yeah?
So you could probably get something interesting done by playing with those guys for a little bit anyway.
Oh, I have never talked to them before because I always thought sort of, well, the hardware part is sort of the part we're trying to sort of get out of the equation, so not having to plug a new device in, but maybe the context will help.
Yeah, it might be worth knowing. I'm happy to tell you.
Oh, sure. Any other? At least your eyes are open, so it looks like it. Yeah. Yeah.
Are there only specialized PLCs, or is it possible to build some kind of generic PLC into every single software?
Yeah, the thing is, let's say these devices, they are very, very limited in their computational capacity and memory. But one thing they're really, really good at is being insanely fast. So if you wanted to sort of use standard hardware or standard operating systems, it's way out of their league to sort of be able to control devices at that speed. There are devices, and we, for example, have at the PLC4X hackathon, we have sort of from, there are quite a lot of devices that have sort of like a real-time modified Linux distribution running on them. So there are software PLCs, but you can't just sort of use a Raspberry or a normal Linux distribution. You really have to sort of mess with the internals to get up to that speed. And I think if you're sort of talking about some CNC machinery, I doubt that with one of these you will get the performance you would need to do that.
Any last questions?
Well, then all I can do is thank you for coming. If you're interested in the project side of this thing, because sort of it was also my first time to sort of start an Apache project and bring it through the incubator. I think a little bit later in the community track, I'll sort of be putting a focus on the community side of this whole project. Might be interesting for the one or other of you. Well, then, thanks and enjoy lunch.
Thank you, everyone.